The webbing will wind onto this aluminum spool in the retractor, a rewind spring keeping it taut. Sudden deceleration will cause this silver ball to trigger the locking mechanism. This will stop the spool from rotating and lock the webbing. This next robot assembles what's called the pretensioner mechanism. While the locking mechanism stops the webbing from lengthening, the pretensioner sharply pulls the webbing back, tightening any slack. The pretensioner kicks in only in the event of a crash. The sudden deceleration on impact triggers sensors, which will signal the airbag control module to send an electrical charge to the pretensioner. This charge sets off a tiny explosion that deslacks the belt. This worker installs the explosive device called the micro gas generator, or MGG. After lubricating the inside of its aluminum cylinder with grease, she inserts a piston and the MGG. The MGG contains a chemical called nitrocellulose. The electrical charge coming from the airbag control module ignites this chemical, causing a tiny gas explosion. That generates pressure within the cylinder, driving the piston upward at high speed. This triggers a gear that winds the retractor spool backward, taking up any slack in the webbing. After capping off the microcast generator's housing, a robot transfers the completed pretensioner mechanism to the retractor's frame. Then it screws on a steel cover plate to hold the pretensioner in place. They install the rewind spring onto the spool of the retractor mechanism. This spring is what provides resistance when you pull out the webbing to buckle up. Then when you unbuckle, it rotates the spool to rewind the webbing. The car company decides what type of spring to use. The thicker the spring and the more coils, the greater the tension, and therefore the faster and smoother the belt retracts. But the greater the tension, the less comfortable the seatbelt is on the body. The webbing is made of woven polyester fiber. This machine sews one end over into a loop for the pin that'll anchor the webbing to the spool. The pin is made of either plastic or steel, depending on the type of retractor they're using. A worker now threads the end through a machine that automatically winds the webbing onto the retractor spool, making sure the pin is properly attached. At the same time, the machine checks the overall belt length to make sure it conforms to the client's specifications. At this factory, every single seatbelt component has to pass a thorough quality control check. Here, a machine checks a key safety feature, a lever and ratchet mechanism that prevents the webbing from extending after you've belted in a child car seat. Now for the final assembly. Workers load all the seatbelt parts in a jig, a holding device that arranges them in the proper configuration. A worker feeds the webbing through the shoulder loop from which the belt hangs, and through the tongue plate, the part that clicks into the buckle. Both these components are made of steel for strength, with plastic coverings matching the car interior. The last step is to sew the anchor to finish off the other end of the webbing. Every seatbelt design goes through extensive testing before going into production. This machine assesses how much pull the webbing and retractor can withstand before breaking. This machine tests the webbing's durability, running it through 50,000 abrasion cycles to ensure the material doesn't wear out.